For over a century, gasoline has been the fuel that powers road transportation. The smell of fuel and the sound of engines roaring to life are things we've come to know. But change is in the air. Elon Musk has always been the person to challenge what others thought impossible. He made electric cars popular when no one believed they could work, and he built rockets that landed on their own when experts said it couldn't be done. Now there's talk of something even bigger, a water-powered engine. But how could a water-powered engine possibly work? And why would Elon Musk, who once dismissed hydrogen fuel cells as pointless, suddenly take an interest in them? Stick with us because what you're about to learn will blow your mind, the mystery behind the water engine. You might be wondering, how can water power a car? It sounds like something out of a science fiction movie, right? The truth is, the idea of a water-powered engine isn't entirely new. People have been experimenting with it for decades, but it's never been taken seriously until now. Imagine an engine that runs on water, no gasoline, no oil changes, no emissions, just pure, clean energy. It sounds almost too good to be true, and for a long time it was. The big question has always been, how can water become a source of energy? Water doesn't burn like gasoline or diesel, so how could it possibly power a car? The answer lies in splitting water into hydrogen and oxygen through a process called electrolysis. Hydrogen is a powerful fuel that, when used in a fuel cell, can generate electricity. This electricity can then power the car. In simple terms, electrolysis uses an electric current to separate hydrogen and oxygen in water, and the hydrogen can then be captured and used as fuel. What makes hydrogen so incredible is that when it's used in a fuel cell or burned, it only produces water vapor as a byproduct. No harmful emissions, no pollution, just clean energy. However, there's a challenge. The current methods of splitting water are inefficient and require a lot of energy. For the process to be worthwhile, the energy needed to separate the hydrogen must be less than the energy we get from using the hydrogen. That's where things get exciting. Elon Musk is known for making the impossible possible. Look at Tesla. People once doubted that electric cars could compete with gasoline-powered ones, but now Tesla is leading the charge in the electric vehicle revolution. If anyone can crack the code to making water-powered cars a reality, it's Elon Musk. Musk has even hinted that hydrogen-powered cars might be the next breakthrough for Tesla. There are rumors that Tesla is working on a new kind of fuel cell technology that could unlock hydrogen's potential in ways we've never seen. Instead of relying on large, expensive tanks to store hydrogen, Tesla could potentially find a way to make the fuel lighter, cheaper, and more efficient. But here's the catch. Hydrogen fuel cells are not a new idea. In fact, companies have been working on them for years, but they've struggled with being too expensive and inefficient. That's where Musk comes in. Over the past few years, Musk has been exploring alternatives to traditional battery technology. Instead of only focusing on lithium-ion batteries, he's reportedly been investing in research into using water as a fuel source, a development that could be a game-changer for electric vehicles. There have even been whispers that Tesla is secretly working on a prototype for a car that runs purely on water. If this becomes a reality, it could be the breakthrough that changes the entire auto industry. When people think about a car running on nothing but water, it might sound like science fiction. But that's exactly what some scientists and innovators, Elon Musk included, are working to make possible. If water can be used efficiently as a fuel source, it could revolutionize the way we think about transportation. If hydrogen can be used to power a car efficiently, it could completely transform the automotive industry. There's no doubt that traditional cars that rely on fossil fuels like gasoline and diesel have serious drawbacks. These fuels are not only finite, but they also contribute significantly to environmental harm. carbon emissions from gasoline engines are among the leading causes of climate change. This is why scientists are searching for cleaner, more sustainable energy alternatives, with hydrogen fuel cells being one of the most promising options. But why hydrogen? And how could it change everything? Hydrogen is the most abundant element in the universe, and when it's used as a fuel, it only produces water as a byproduct. This means it's clean, renewable, and could potentially replace gasoline as the fuel of the future. However, there are still significant hurdles to overcome in making hydrogen fuel a practical solution. The technology to efficiently extract and store hydrogen has always been expensive. The equipment required to produce and store hydrogen safely is costly, and the current method of producing hydrogen from water is energy-intensive. Right now, it takes a lot of energy to extract hydrogen from water in a way that is economically viable. To make water-powered cars a reality, we would need to find a more efficient and cost-effective way to produce hydrogen. Imagine an engine that uses water, extracts the hydrogen, and then uses that hydrogen to power the car. If the process of producing the hydrogen is too costly, the cars themselves will be too expensive for most people, making it hard for water-powered cars to become a viable option. Then there's the storage challenge. Hydrogen gas is highly volatile, and storing it safely and efficiently is a major problem. This is why hydrogen-powered cars aren't more common today. Hydrogen is lighter than air, and if not stored properly, it can leak or cause accidents. Engineers are working hard to create safer, more durable storage solutions, but it's still a tough challenge. Even if the technology for safely storing and transporting hydrogen becomes reliable, there's still the question of infrastructure. Establishing a network of refueling stations for water-powered cars would require substantial investment. It's not just about building new stations. We would also need to train people to handle hydrogen fuel and ensure that the stations meet strict safety standards. Despite these technical challenges, the concept of water-powered cars remains incredibly appealing, especially when it comes to their environmental benefits. Elon Musk has always been a strong advocate for sustainability, and this vision aligns with his commitment to a cleaner future. The environmental advantages of water-powered cars are striking. Cars that run on water could drastically reduce harmful emissions. Imagine cities where streets are free from the usual smog and air pollution. Such a change could dramatically improve air quality, especially in areas struggling with pollution. In fact, much of the pollution we experience today is directly linked to the fuels used in cars. Traditional gasoline and diesel engines release harmful chemicals into the air, contributing to global warming and various health issues. On top of that, there's the question of long-term sustainability. Water, on the other hand, is abundant, and if we can efficiently extract hydrogen, it could provide an almost endless source of energy for our cars. This would drastically reduce our reliance on fossil fuels, which are not only finite but also harmful to the environment. Elon Musk's dream of a world where cars run on water may seem far-fetched, but the environmental benefits are too significant to overlook. The idea could fundamentally change how we think about energy. But what if there was a way to simplify the process? What if creating hydrogen could be more efficient and cost-effective? Musk has hinted that a breakthrough may be on the horizon. If he's right, there could come a time when cars no longer rely on gasoline or electricity, but instead run on something clean and limitless: water. Hydrogen gas, which can be used as fuel, is lightweight and contains a lot of energy, which is why hydrogen fuel cells can power vehicles. The oxygen produced during this process simply gets released back into the air as a harmless byproduct. If we can use hydrogen efficiently, all that would be emitted from the car is water vapor. The problem, however, is that electrolysis, the process of splitting water into hydrogen, requires a lot of energy. This has made it expensive up to now, But Elon Musk has been optimistic about breakthroughs in energy storage and efficiency that could make this process far cheaper. Tesla has already made strides in energy storage with its Powerwall technology, which stores solar energy for home use. So, if Tesla can figure out a way to make hydrogen production from water more affordable and efficient, it could change everything. What's even more exciting is the idea of self-sustaining systems. Imagine a car that, when running low on fuel, could extract hydrogen from water in its own tanks. That's the dream. A car that doesn't need to stop at a gas station or charge at an electric charging point. It could just refuel with water. Tesla has always pushed the envelope when it comes to innovation, from autonomous driving to electric powertrains. Elon Musk's companies have taken risks that many other automakers would shy away from. This spirit of innovation could eventually lead to a major shift in how we think about fuel. Now, let's consider the potential impact of water-powered cars. If this technology becomes affordable and practical, it could completely disrupt the automotive industry. First, consider the current fueling infrastructure. The world is built around gas stations and electric charging points. For hydrogen-powered cars to go mainstream, a whole new network of fueling stations would need to be created. But here's where water-powered technology really stands out. Instead of depending on large, expensive fuel stations, water-powered cars could refuel almost anywhere. Hydrogen could be extracted from water using simple equipment, so a car could pull over to a river or even a tap to get its energy. This could revolutionize mobility. You wouldn't have to drive to a gas station or search for an electric charging point. The future of cars could be much simpler, just water and a little electricity. Imagine the environmental benefits. Water-powered cars produce zero emissions. That would mean a world where cars no longer pollute the air or contribute to climate change. Every water-powered car would leave only clean air behind, helping the planet breathe a little easier. If water-powered cars become a reality, the fuel industry could face new competition, one that is clean and sustainable. This shift could even push traditional car manufacturers to transition to more eco-friendly models. However, for this to happen, the technology needs to be reliable, safe, and efficient. That's what experts, including Elon Musk, are working towards. It's clear that the water engine isn't just a far-fetched idea, it's a technology that could change the world. The potential to disrupt the automotive industry and revolutionize how we think about energy is immense. Musk's belief in this technology shows just how committed he is to bringing innovative, sustainable solutions to the world. But while the potential of the water engine is exciting, there is still a long way to go. Research, development, and breakthroughs are needed. Governments, industries, and scientists must collaborate to figure out how to bring this game-changing technology into the mainstream. If Elon Musk's track record is any indication, we could be looking at the future of transportation, a future where the water engine leads the way in automobile innovation. As the world increasingly focuses on sustainability, clean energy, and reducing carbon emissions, the shift toward alternative energy sources for transportation has become a central topic. Among the key players driving this revolution are influential figures and regions, including Elon Musk, China, and Dubai. Recently, these three have made headlines with their plans to develop water-powered cars, a move that promises to reshape the automotive industry and speed up the world's transition to cleaner energy. Though each has a unique approach to this groundbreaking technology, together they are poised to lead us into a new era of sustainable transportation. So, are water-powered cars really on the horizon, or is the future already here? Stay tuned to find out. Elon Musk, the renowned entrepreneur behind Tesla, SpaceX, and other ventures, has long been an advocate for sustainable energy. His work with Tesla has primarily focused on electric vehicles, which are hailed as a major solution to the world's dependence on fossil fuels. But Musk's broader vision for the future of energy extends far beyond electric vehicles. He has consistently pushed for a total transformation in how humanity generates, stores, and consumes energy, particularly in transportation. Tesla is already leading the charge in the EV era, and now they are expanding their charging network to include vehicles made by other manufacturers. Musk's goal has always been to drive the world towards cleaner, more sustainable energy, and the potential for water-powered cars could be the next big leap in that vision. The introduction of water-powered cars marks a bold and ambitious step forward in Elon Musk's vision for sustainable energy. Musk's push to develop water-powered vehicles is driven by his commitment to reducing the global carbon footprint and addressing the environmental harm caused by traditional fuel sources. Although the concept of using water as a fuel has been explored by scientists and engineers for years, Musk's ability to combine cutting-edge technology with innovation is bringing this idea closer to reality. Water, an abundant and renewable resource, holds the potential to replace fossil fuels, which have long dominated the global transportation sector. The science behind water-powered cars is based on a process called electrolysis, which splits water molecules into hydrogen and oxygen atoms. The hydrogen, once separated from the oxygen, can be used as a fuel source. While the use of hydrogen as fuel has been studied for decades, the breakthrough Musk's Tesla team is working on focuses on developing a more efficient method of electrolysis. For Musk, water-powered cars are not just an environmentally friendly solution. They are also part of a larger strategy to challenge the geopolitical and economic issues tied to the world's reliance on fossil fuels. The instability of oil prices and the environmental damage caused by the extraction and burning of fossil fuels have made it clear that a cleaner, more stable energy source is needed. Musk's vision of water-powered cars addresses these challenges, offering a fuel that is both universally accessible and abundant. However, Musk and Tesla are not the only ones working on water-powered vehicle technology. China has also made significant strides in this area, announcing their own plans to develop water-powered vehicles. As a country that has rapidly become a global economic powerhouse, China has been recognized for its technological advancements, especially in renewable energy and electric vehicle development. As the world's largest auto market, China has been leading the charge for cleaner, more sustainable energy sources. China's energy needs are immense, consuming about a quarter of the world's energy supply, 35% more than the United States annually. The country's energy demands have more than tripled since 2000. With ambitious targets set for reducing carbon emissions and achieving carbon neutrality by 2060, China views the development of water-powered vehicles as a key part of its strategy. China's growing interest in hydrogen as a fuel source has been evident for years, and the country has already invested heavily in hydrogen-powered vehicles. Moving toward water-powered cars takes this concept a step further by combining hydrogen fuel cell technology with water electrolysis. This approach aims to create a more sustainable and efficient method of producing hydrogen, reducing reliance on fossil fuels and creating a closed-loop system that greatly minimizes environmental impact. China has made great strides in green technologies, from solar power to electric vehicles, and the introduction of water-powered cars is a logical next step in the country's ongoing efforts to reduce its environmental impact. In recent years, the Chinese government has put significant emphasis on developing renewable energy, electric vehicles, and hydrogen fuel cells. With a strong foundation already laid for the widespread adoption of electric cars, China's new plans to produce water-powered cars show its ambition to become a global leader in hydrogen technology. Major Chinese automakers such as BYD, Geely, and NIO are already testing hydrogen-powered vehicles and exploring the use of water as a fuel source. The country's approach to water-powered cars involves integrating renewable energy sources like solar and wind with water electrolysis systems. In this vision, electricity generated from renewables will be used to split water molecules into hydrogen and oxygen, providing a clean and sustainable hydrogen fuel supply for vehicles. This model not only supports the global transition to clean energy, but also creates a self-sustaining energy ecosystem resilient to the challenges of fossil fuel reliance. Meanwhile, Dubai is also joining the race to develop water-powered vehicles. Known for its luxury lifestyle, iconic skyscrapers, and technological advancements, Dubai has announced plans to develop water-powered cars, aligning with the efforts of Musk and China to reshape the future of transportation. The city, long a hub for innovation, has earned global attention for its ambitious projects and forward-thinking initiatives. Dubai's ruler, Sheikh Mohammed bin Rashid Al Maktoum, has made it clear that the city is determined to lead the global push for sustainability, and the introduction of water-powered cars is part of this vision. Dubai's decision to explore water-powered vehicles reflects its commitment to creating a more sustainable, environmentally conscious city. This marks a significant shift away from the region's traditional reliance on fossil fuels and represents a bold step toward embracing renewable energy. The city has already positioned itself as a leader in clean technology development, with its Road and Transport Authority recently winning the Middle East and North Africa Green Building Award in the Green Building Project of the Year category. Water-powered cars are expected to play a major role in the city's future. The UAE government has committed to ambitious sustainability goals, including reducing carbon emissions and increasing the use of renewable energy. Though the water-powered car initiative in Dubai is still in its early stages, the city has made notable progress in building the infrastructure necessary to support this technology. However, as with any groundbreaking plan, there are challenges to overcome. Keep watching to find out the difficulties involved in developing water-powered vehicles. The emergence of this new technology promises cleaner energy and reduced carbon emissions, but even with bold announcements from Elon Musk and others, there are still obstacles ahead. China and Dubai have ambitious plans to develop water-powered vehicles, but the journey to making this technology a reality is far from straightforward. While the idea of water-powered cars is exciting, there are several challenges and setbacks that have slowed progress. These obstacles span technical, economic, and infrastructural areas, creating significant hurdles that have yet to be fully overcome. One of the main technical challenges is the process of electrolysis, which is central to using water as a fuel. Electrolysis involves splitting water molecules into hydrogen and oxygen using electricity, a process that is both energy-intensive and costly. Traditionally, the energy required to break down water into hydrogen has often exceeded the energy that can be extracted from the hydrogen itself, making it an inefficient process. Although there have been advancements in improving the efficiency of electrolysis, these breakthroughs are still in the early stages, and the technology isn't yet perfected enough to make water-powered vehicles viable for mass production. Even with improvements to electrolysis, hydrogen storage remains a significant problem. Hydrogen gas, the fuel produced through electrolysis, is highly volatile and difficult to store efficiently. Traditional hydrogen storage methods, such as compressing hydrogen into tanks, are expensive, bulky, and pose safety risks. Additionally, hydrogen's low energy density means that large storage tanks are needed to provide a substantial driving range, complicating the logistics of producing and maintaining water-powered cars. While some companies are working on lighter and safer storage solutions, this technology is still in development and hasn't yet been widely adopted in the automotive industry. Another major issue is the lack of infrastructure for hydrogen refueling. Unlike traditional gasoline stations or electric vehicle charging points, hydrogen refueling stations are rare and mainly located in a few key regions, such as California in the United States. For water-powered vehicles to become a viable option for consumers, an extensive network of hydrogen refueling stations would need to be established. Building and maintaining this infrastructure would require significant investment from both the public and private sectors. Without such a network, water-powered cars would face the same challenges early electric vehicles encountered, such as range anxiety and limited refueling options, which could deter consumers from adopting the new technology. The economic viability of water-powered vehicles is another major challenge. Although using water as a fuel source is attractive due to its abundance and renewability, the cost of developing water-powered vehicles remains high. The advanced materials and technologies needed for electrolysis and hydrogen storage are expensive, and the manufacturing processes for these vehicles are not yet optimized. As a result, production costs are likely to stay high in the near future, making it difficult for companies like Tesla to bring water-powered vehicles to market at an affordable price. For automakers in China and Dubai, making water-powered vehicles affordable for the average consumer will take time. Until economies of scale are reached and production becomes cheaper, water-powered cars are likely to remain a niche market for wealthy early adopters. There's also the challenge of public perception and consumer acceptance. Hydrogen as a fuel source has faced skepticism for years, mainly due to safety concerns, as hydrogen gas is highly flammable. Despite safety measures in place for storage and use, many people still view it as a risky fuel source. This skepticism extends to water-powered cars, which are largely seen as a concept rather than a practical option for everyday transportation. Changing public opinion will require significant education and marketing efforts to show that hydrogen fuel cells and water-powered cars are safe, reliable, and efficient. The transition to water-powered vehicles also faces substantial geopolitical and economic challenges. Reducing dependence on fossil fuels could disrupt oil-producing countries, many of which rely heavily on petroleum sales. This could lead to resistance from nations and industries that are deeply invested in the current energy system, slowing down the adoption of water-powered cars and hindering the development of the necessary infrastructure. International cooperation will also play a critical role in overcoming logistical challenges as countries like China and Dubai work on developing water-powered vehicles. However, differences in hydrogen production, storage, and refueling standards could complicate the global supply chain. Geopolitical tensions and varying regulations might delay progress even further. The scale of the transition is another huge obstacle. The automotive industry is massive, with millions of gasoline and diesel-powered vehicles around the world. Moving to water-powered cars would require massive investments in the innovation and infrastructure, which will take time. This shift won't happen overnight and will require ongoing collaboration between governments, corporations, and consumers. Overcoming the technical, economic, and political challenges will be a long-term process, and while progress is being made, it will take years for water-powered vehicles to become widely adopted. That said, this transition could open up opportunities for hydrogen-powered vehicles to excel in areas where battery electric vehicles may struggle, such as long-haul trucking, heavy-duty transportation, and remote locations where charging infrastructure is limited. Hydrogen can be produced from various renewable sources such as solar, wind, and hydropower, making it a truly sustainable fuel. When hydrogen is produced via electrolysis using renewable electricity, the entire process is green, resulting in zero emissions from production to consumption. This positions hydrogen as a key player in the global shift to clean energy and a low-carbon economy. Building on the success of the Toyota Mirai, Toyota continues to develop hydrogen technology, bringing it into new forms and applications. The latest evolution of this effort is the Corolla Cross Hydrogen 2, which uses hydrogen power in an internal combustion engine ICE rather than a fuel cell like the Mirai. This shows how hydrogen combustion engines could complement the fuel cell technology used in earlier models. Toyota's innovation demonstrates how far they can push the boundaries of sustainable transportation, potentially revolutionizing the world with new technologies. While hydrogen fuel cells are efficient at generating electricity, the combustion engine approach offers another pathway to clean transportation by directly burning hydrogen. This allows Toyota to utilize existing ICE technology in a more sustainable way, potentially lowering the cost of transitioning to hydrogen-powered vehicles by building on established manufacturing processes and infrastructure. The hydrogen combustion engine preserves many of the qualities that drivers are used to, such as the familiar sound, feel, and response of a traditional engine, but with much lower emissions. For car enthusiasts who are hesitant to switch to electric vehicles because of the difference in driving experience, hydrogen combustion offers an exciting alternative that blends the best of both worlds. The main difference between Toyota's hydrogen and hybrid engines and conventional gasoline engines lies in the fuel source and combustion process. Traditional gasoline engines burn fossil fuels, releasing harmful emissions like carbon dioxide, nitrogen oxides, and particulate matter. In contrast, Toyota is pushing forward with alternatives that produce significantly fewer emissions while still offering high performance. A conventional engine relies on gasoline for energy through combustion, whereas Toyota has perfected the use of hydrogen as a clean and efficient fuel for its powertrains. Hydrogen-powered engines maintain the core characteristics of traditional engines while dramatically reducing environmental impact. Switching from gasoline to hydrogen or electric power not only eliminates carbon dioxide emissions, but also provides a pathway to sustainable transportation without sacrificing the driving experience or engine performance. Toyota's hydrogen engine technology is built on a blend of modern engineering and fuel innovations. One of Toyota's most impressive achievements is maintaining engine performance with hydrogen as the fuel source. This breakthrough lets drivers enjoy the same power and responsiveness as traditional engines, while eliminating the harmful emissions linked to gasoline. A key part of Toyota's hydrogen engine design is the advanced high-pressure hydrogen direct injection system. This system efficiently delivers hydrogen into the engine's combustion chamber, where it is ignited to generate energy. The high-pressure injection allows for precise control over the fuel flow, optimizing combustion and ensuring maximum power output with minimal waste. This innovation ensures that Toyota's hydrogen engines offer the same performance as gasoline engines while providing cleaner and greener solutions. Hydrogen, being less energy-dense than gasoline, poses a challenge because it contains less energy per volume. To overcome this, Toyota has incorporated turbochargers into its hydrogen engines. Turbochargers compress air and boost energy efficiency, helping the engine generate enough power to make up for hydrogen's lower energy density. By compressing the air intake and increasing oxygen levels in the combustion chamber, the turbocharger allows the hydrogen engine to deliver performance on par with traditional engines without sacrificing acceleration or power. The use of turbochargers is vital for balancing high power output and low emissions. Toyota's engineers have expertly integrated this technology into their hydrogen powertrains, giving drivers a dynamic and responsive driving experience, all while reducing their carbon footprint. What do you think? Will this technology live up to the hype? And how soon do you think it will be ready to change the world as we know it? Share your thoughts in the comments below. If you enjoyed the video, don't forget to like, share, and subscribe to our channel. Also, click on the next video on your screen. We think you'll enjoy it.